Welcome to this tutorial in which I will answer some frequently asked questions on our discussion board. In this week, the most frequent questions were: how do I remember the formula for variance and standard deviation, and how to type formulas for variance and standard deviation in Excel. The key to remembering formulas for standard deviation and variance is actually to understand the deviations from the mean. Deviations from the mean are related and are connected to one of the definitions of mean value. In some books, mean value is defined as such a value for which all deviations from any values in the database in the data set to the mean is equal to 0. And I would like you to kind of get some sense of this. I use not real data, but simple data of 6 values, and I calculated the real mean, which is 4.6. And as you can see, some of the deviations are above the mean and some of the deviations are under the mean in this scatter plot. And the reason that this sum of the red and blue is always 0 is because this is how the mean is defined. It is a value that creates zero sum of all distances to this specific value of the mean. So here the purple line is the mean, and the values to the mean are presented with blue lines if the values of our variables are below the mean, and with red lines, well, the values are above the mean. So this visualization of the most frequent expression x minus mu, or x minus x bar, which is called deviation from the mean, is kind of visualized in this case, and I hope that you will remember the visual symbol of deviations from the mean. How statisticians can resolve this problem, how they resolve this problem. Actually, one way to get rid of those zero-sum problems is to square all deviations from the mean first and then to add them. When you square a negative value, the square is positive, and that way the elimination of positive and negative deviations, the sum of positive and negative deviations is always 0. So if we square all deviations, we will have non-zero formula for the sum of all squared deviations, except of course if the distribution is uniform, all x values are equal to the mean, which is a case in which we don't have spread around the mean. Another reason that this is very important to understand is that in the model for normal distribution, which is given with Gaussian formula, the deviation from the mean is squared to the power of 2 in this formula. So deviations from the mean is very important, and this is why statisticians use deviations from the mean squared in the formula for variance. This is the formula for variance, and the formula for standard deviation. This is variance of a sample, and you can see that we use x bar for mean of a sample, and n-1, which is corrective factor. We use n-1 to correct for the fact that when we select a sample, we are losing part of the spread around the mean. The standard deviation is S or sigma in case of the population, and the symbol for mean is mu divided by the total number of cases in the population. And how do we type those formulas? Well, in Excel, in Microsoft Office, in any modern software for presentations and writing, we actually insert formulas. In more old variant, we insert an object, and now in Microsoft 10, we have a special place, a special toolbar for inserting formulas. So let's go now and try to type a very simple formula of variance. And first I will show you how to insert formula of variance in here. You click on insert and then you select this pi symbol, which is a toolbar, and under pi you have all tools for typing formula. First of all, whenever you are trying to type exponent, you need a place value for the base. In our case, the base is the standard deviation symbol, or S. Then we need the exponent, which is 2. And then the formula for variance needs a place value, placeholder for fraction, because the variance is fraction of all square deviations. So first we have to find the sum, and then squared deviation. So we need exponential notation, this exponential symbol. The deviation from the mean is x minus, in case of sample, x bar. So you see where is x bar, this place here, x bar. Then you have to click on the to get out of the bar symbol, and I hope I'm out. No, I'm not. So I use the right arrow on my keyboard, and that way I get out of this x bar placeholder. Click 2 on the exponential placeholder, and then n-1 for variance. Now I will really try to show you what happens if you want variance of the population. Then you click sigma, and this is the toolbar with Greek letters. Instead of x bar, you need Greek letter mu. Okay, and then instead of n-1, you need capital N, uppercase N, in case of variance for the population. Now, standard deviation is root square of the variance, and I would like to show you how to type this formula to finish this lesson. Insert pi, and you start with root square, the very first, the very simple one. Of course, don't forget the equal sign, because this means multiplication. So let's put equal sign and then division line. Now let's remember that we are working with a sample. Sum, I need exponential notation because all deviations from the mean are squared. So x minus x bar, you see these are all symbols with something above, like this bar, and then right arrow on the keyboard to get out of the bar symbol. Place value for exponent, you put 2, and then you divide by n-1. I also like when students present in their work what is each symbol. Sigma is a symbol for sum, x bar the mean of a sample, and n is the size of a sample. Have a very good week.